Okay, we now have succeeded with our parsing of our input commands. And now we need to do something with these commands. And really what we want to do is we want to create some sort of command set that our cleaning robot can take as a set of input commands. But obviously we don't have any command set yet, so we need to go into that. If we go back to our last test, create a new test method. And here we're going to have command factory. We are going to obviously the command factory takes inputs until the inputs are complete, at which point we should be able to extract a command set. Until the number of inputs are complete, we shouldn't be able to extract a command set. So if we add incomplete inputs, and the result should be a null command set. So we've got our command factory. This is a complete set of inputs, so we want to give it something which is an incomplete set of inputs. And we will create a command factory dot get command set. Right, which returns okay, so we've got the command set method which returns command set, and we actually what we want to check is that since we know that these sets of inputs are incomplete, the command set should be null. Okay, so that's great. Now we need to generate the method. If we go to the declaration here, we are throwing nothing. Now, what is this command set? What do we want to have in this command set? Well, we want to have some of these bits of information we have. For example, we would like to know the number of commands. We would wish to have the start position and also the set of moving commands. These three would we like to have. So we can use our resharper, refactor, extract class. We don't need the input strings, and this will be called a command set in its own file. Yep. Okay, so now when we create, instead of having those initial variables, we have actually got a command set. And let's just check. And of course we've got private fields. So what we want to do is change those out to public fields because we need to access probably the number of commands. So we go to command set, and if we change that to well, actually we want these probably private. Private internal commands, private location, and then private list. Yep, that's fine to start with, and then we need to have some public access as this. Public return. So for number of commands, we want to do the same for the start position and the movement commands. Okay. We'll go back to our command factory here. This we want to edit, find, quick place, start position with dot start position. And the same for number commands. Yes, 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 yes. Okay. Number commands here we need. Okay. Start position. Right. Looks starting to look good. What is the problem here? Aha, this is hold on, small s, big S. Okay, we go to this. Okay, cool. Rebuild. Are we still getting okay? There. Public command set. Okay, and here we've got the tests. So we need to do the same thing here. We need to do a quick replace. One more. We need to do movement commands. Okay, let's build again. Okay, so now with command factory, instead of having its own internal variables, we're actually creating a command set. And right now we've got the method giving a command set, and here we should check if inputs are complete. Wait, we don't want static. Hold on. If inputs are complete, then we want to return the command set. Otherwise, we are returning a null. Okay, rebuild. So, rebuild. It's not a static variable. It's an instance method. And now if we run our unit tests. Okay, good. So we've commands factory knows that there's 5 commands coming. There is only one command there, and so it does not return a command set. We need to create another test to check what happens when we have a complete command set. Adds complete inputs, not null command set. So let's change that to 5. Let's give it 5 commands. 2, 3, 4, 5. And then assert dot is not null. Rebuild. Deep run your tests. Yes. There we go. So now we're returning our full command sets. Okay. We should probably do some more quick tests on our command set. Let's just check the number of commands, for example. Add 5 commands. Not constant, it has 5 commands. So, command set, and obviously we're not going to assert that, we're going to assert is r equal 5 command sets dot number moving commands dot count. Okay, let's run that test. Great. Okay, we now interpret our inputs and we're creating our command sets. We are actually in the situation where we can actually demonstrate some business value with the demo. We can demonstrate a use case here exactly, which is the robot, once given some instructions, will run on its own. So obviously the first use case here is the giving the robot instructions, and we're able to demonstrate this feature now with the classes that we've built. So why don't we go to our client, and well, actually, first of all, we're going to be using our command factory in our client, so we need to just reset the open up the security levels on that. And now, so if we've got our main program here, we're going to collect a set of inputs from standard in. The robot should execute cleaning commands and give out within a minute. So this first bit we can demonstrate now. So if we create a command factory, okay, and we can say while command factory dot inputs are incomplete, we want to command factory, we're going to add an input. We need to open that up as well. Command factory dot add input. I tend to be very conservative with my security levels and only allow when absolutely necessary. Add input console dot readline. Okay, so we're going to add one line of text. Add it into the command. And then we will console dot write line inputs complete. Press any key to continue. Okay, so we can test this. Okay, everything's built, ready to run. While inputs, well, obviously while the inputs are not complete, we want to keep taking inputs. So we've got an input, and if we go back to our command factory tests, we've got some inputs like, here we go. It says 1, 22, 3. So let's give it a command. We're going to send in one move command. The initial start point is 10:33, and we want it to move east 4. Input complete. Press any key to continue. Okay. And let's just run that one more time. This time we're going to give it 4 commands. And the start position is -5, -20. And the first position is east 1, west 2, north 3, north 5. Oh, and there we can see we've got 4 commands, whereas it should be... we did actually say 4 commands. Yes, that's completely correct. Okay, great. Okay, we're able to demonstrate our first use case. Time to move on to the robot.
Okay, so we're going to start with the robot, and we start off with the new unit test. Let's rename that to robot tests. Okay, and the first thing we will test is create robot. So let's create a robot. Right, and what are we going to send to the robot? Well, obviously, we're going to add a command set, so we can do that right away. Let's just create the command set. Actually, let's do this realistically. Let's create a command set factory. Command factory. And we can add some command sets. Add a very simple input. We're going to have no commands. And a position of 0, 0. And that should give us a command set. And then we'll pass that into the new robot. Okay, build it. So we've got to create a new class here. And we want to move that, of course, to our robot cleaner assembly. So here we should robot cleaner. Okay, back to our robot tests. So, rebuild. Run our tests. That's fine. Okay, if we look at our spec again, you can see that the robot, we've given some instructions. We just passed some instructions. It will then run on its own without any interference, and in the morning we can ask the robot to report how many unique places it has visited. Okay. So if we take this test and create a new test, we'll move that to the... Here we've basically given the robot an empty command set. And now we want the robot to execute the commands. We'll call this run robot. And run robot with an empty command set. And the robot position should not change. So we're going to run these commands for movements of the robot, and at the end we can assert that the what are equal command set dot start position dot x should match the robot dot x, and right, so we can't build this, so we've generated a few things here, so let's just generate a method stub for that. Let's just generate a property for that and a property for that. Okay, so we have got fields now, the command set, we've got x and y, which should be an integer. Okay, and obviously once we create the command set, we can set the X and Y. Actually, let's not do that. Let's change this to a public application. We'll just call it position. We'll set the position. So with command set dot start position. We've deleted our. So, oops, there. Should we just put the minimum needed to get this test to run? And at the moment, when we're execute commands, we're just going to do nothing. So let's build that. This can be a read only. Oh, we'll leave that. And of course, this should be robot.position. Okay. Let's run our tests. Excellent. Okay. So we created a robot, but the robot's got to do two more things. It's actually got to execute commands, and it's also got to report all the places it's been. Now, if you're aware of sort of iDesign methodology, you'd say you should try to encapsulate and control your volatiles, the things that will change. So if we look at the project here and see what are the things that are going to change, well, one of the obvious things probably is how we report the what the robot has done. At the moment, it just says in the total number of unique places, but this may obviously change. Probably would change actually. So we want to encapsulate that so that it causes the least amount of stress in the system or change the system whenever we do change the reporting method. So let's look at that right away. How are we going to do that? Well, obviously the robot at the moment takes constructor command set. It might want to give it a method of reporting. So if we do the same test, but now we're going to test the report. Once we've executed commands, we will have a string. Report is equal to robot dot print report. Okay, and here we're going to assert that since it was named command set, so that actually hasn't cleaned anywhere. We're going to assert r equal. What does the entry report look like? What the entry report looks like. Okay, so we have our report. For this we need to generate a method. Run robot empty path report. Place report generated.
So we can run our test now. We've got a failure. Our method is not method operation is not implemented. Okay. And that's this print report method. If we go to our print report method, we can see. Okay, so we also want to print out our report here. And as I said, we want to encapsulate our volatile areas, the areas that are going to change. So to minimize the cost of changing the feature. And the reporting is one of these areas that is likely to change. So we can use the enterprise pattern here to allow us to change how we report very easily. I want to create a shield reporter. And then obviously the recorder is exporter, yes. And then here we want to connect up. So we'll just return reporter dot report. Okay, so in the future, if we want to change what we're actually reporting here, we just need to change the reporter we use in the constructor. And so we don't need to change the code in this robot class at all, which fits nicely with the solid principles. In particular, the open close principle. Since we don't need to change the code here, we just have to extend it. Okay, but we need to generate this interface. And here we have a public interface, which has at the moment has one method, which is public void string return. Okay, and then our robot, obviously we want to will print this report. And so our reporter class we need to create a reporter here for our robot test. So let's create here a new class. Let's reporter test. Let's see, we're just trying to do this so that we implement the minimum amount of changes to get our test pass. We want to implement our interface here and in our robot test. Okay. So this is not likely to add in here. These don't need any reporter at all. Okay, now if we run the robot test again.
Your success now. Okay. We have something interesting here because in these two tests we have used a null reporter, so it wasn't really necessary to have any real reporter for our test. But if we go to our robot class, we can see that it is quite possible to send in a null reporter. And here we normally perhaps would have some sort of guard command that checks that the reporter is not null. And if it is null, then it throws an exception. But in our specification, we have the point that there would be no error reporting. There's no error reporting. So really, what do we do in a situation where we have a null reporter sent in? Obviously we can't report. So we should probably try to do something graceful, just give the minimum report, which should be 0 report. So let's do a test to confirm that that works. We run robot with an empty command set and null reporter. Again, we really what we want is a 0 report generated because we don't know, so we just say we cleaned 0 or something similar. Cleaned, we would actually want to clean perhaps 1. Right, so if we build this, and we don't want the command, we specifically want a null reporter. We run this test now. Okay, we got no object reference exception, of course. So if we go to our robot report method, and here we should have reporter null. Can we run a test now? So we're handling the situation where we have a null report.